Good morning, afternoon, or evening. So, this lesson is not one that's in the book, but it is one that is introducing us to a concept we're going to see next week, and it includes area of the shaded region. So, we're going to give you some problems that only contain numbers. Next week, you're going to see some questions that contain variables, so some linear expressions. So, let's talk about how to do question number one. I gave you a little bit of guidance here. We are trying to find the area of the gray shaded region. In order to do that, we've got to start by finding the area of the whole shape, this entire region that I'm outlining with my mouse here. But take away the part that is not shaded, which is this rectangle that's in the center here. Now, I want us to remember that the area of a rectangle is going to be length times width. So we need to multiply the dimensions. If you're thinking base times height, that works as well. But the area of a rectangle, length times width, and all of these are going to be rectangles, no other shapes here. So in order to find the area of the big or the larger rectangle, the entire shape, we need to multiply the length and the width. So that involves multiplying 10 by 15. So when we multiply 10 by 15, that is going to get us 150 feet squared. I'll go ahead and reveal that work here. So area is length times width. We take 15 times 10 to get 150 feet squared. I'm not too worried about your labels, just knowing that we multiply those dimensions. For the small rectangle, we're going to multiply its dimensions as well. So we're going to take 11 times 6, which is going to get us 66 feet squared. Now, to find the area of the shaded region, let's take the area of the big rectangle, which was 150, minus, we've got to take away the part that's not shaded, the area of the smaller rectangle, which is 66, and that gets us the area of the shaded region, which is 84 feet squared. So again, we take the area of the whole shape minus the area of the part that's not shaded to get our solution. Let's take a look at number 2. So to find the area of the shaded region, let's start with the area of the big rectangle, the whole thing. The dimensions are 18 and 12. So we're going to do 18 times 12. Now I wrote it as area of the big rect. I didn't put rectangle there. But we're going to take 18 times 12 to get that. That's going to get us an area of, whoops, I moved the wrong shaded region there. So we are going to get an area of 216 feet squared. But again, I want to take away the area of the part that's not shaded, and those dimensions are 12 and 6. So the area of the small rectangle, and I do think it's helpful to label your work, the area of the small rectangle is going to be 12 times 6. Now, right now, some of you are thinking, do I have to write area equals length times width every time? No, but I will list it every time so you see where I get that from. So we take 12 times 6, and the area of the small rectangle will be 72 feet squared. Make sure you're copying all of this work into your notes, pausing as needed. Now, to find the area of the shaded region, we are going to take the area of the big rectangle, which was 216 feet squared, minus the area of the small rectangle, which was 72 feet squared, and we get the area of the shaded region to be 144 feet squared. All right, question number 3. So this one is going to be a little bit harder for us. So it says a pool is surrounded by a cement walkway that is 3 feet on each side. So what you notice is missing on your paper is the dimensions on the outside, but we do know that the width on each side for this walkway is 3 feet. So the first thing that we're asked to find is the dimensions of the larger rectangle, which we're going to be able to find. So I'm going to draw some lines in here, and what I know, we'll try to make this color-coded here, is that the distance between these two sort of greenish lines that we have here is going to be 10 feet. So we can label that part right there between those two green lines as 10 feet, the same as this unshaded rectangle's length or larger dimension. Now, what we know is between the green line and the end here and the green line and the end here is that each of these distances are going to be 3 feet. So if I want to find the total length of the larger rectangle, I need to take 10 plus 3 plus 3, which is going to get us 16 feet. And again, you may want to put someplace where you get those from. So maybe writing 10 plus 3 plus 3. Now to find the shorter side, again, I'll draw some lines in here. Go ahead and make those just a different color here. So between these two bluish lines that we have here, we know that this distance is 7 feet. Same as the shorter side of the interior rectangle that we have. Now we have 3 feet up here, okay, since it is 3 feet between your center rectangle, your unshaded rectangle on the end. So it's 3 feet here, and also going to be 3 feet down here between the blue line and the bottom, since that walkway is 3 feet on all sides. So in order to figure out this shorter side, we've got to do 7 plus 3 plus 3, which is going to get us 13 feet. So the dimensions of the larger rectangle are 16 feet by 13 feet. Now what's going to be coming up is we're going to throw some variables into the mix eventually. Right now we're just sticking with numbers, but this is a little harder than the last two. So to find the area of the shaded region, we're going to start by finding the area of the larger rectangle, or the big rectangle in this case. Our dimensions are 16 by 13. Those are the ones we found in part A. 16 times 13 is going to get us an area of 208 feet squared. Now the smaller rectangle should be really easy. We're going to multiply 10 times 7 to find the area of the unshaded rectangle. 10 times 7 gets us 70 feet squared. Now to find the area of the shaded region, remember we want to subtract those. 208 feet squared minus 70 feet squared is going to be 138 feet squared. This one's a little bit harder and a little bit more like the ones we'll see next week, where we are missing the dimensions of the larger rectangle. So let's practice this again. Taking a look at this next problem, and my picture is not necessarily drawn to scale. It says a garden is surrounded by a walkway that is 4 feet on each side this time instead of 3 feet. We're going to find the dimensions of the larger rectangle. So let's describe how to find this. Let's put some lines in here, choose some different colors. We'll start with blue. So I know that this distance between these two blue lines is 6 feet, this number right here. And then we have 4 feet on each side. So in order to figure out this entire length right here that I'm going to highlight in green, let me grab my highlighter. In order to find this entire length, I've got to take 6 plus 4 plus 4 to get that. 6 plus 4 plus 4 is going to get us 14 feet going across. I hope I get that correct. 6 plus 4 is 10, 10 plus 4 is 14 feet. Now, to find this other side, I know that the distance between the two, let's pick a color here, let's make them green. The two green lines that I have is going to be 8 feet. So this distance here is 8 feet. But then I have 4 on either side. So to find this entire length along this right-hand side and the left-hand side, I've got to do 8 plus 4 plus 4. And that is going to get us 16 feet for that dimension. So the dimensions of the larger rectangle are 14 feet by 16 feet. So when we find the area of the big rectangle, we are going to do 14 times 16, which will get us 224 feet squared. Now, the area of the smaller rectangle should be easy for us. We are given the length and width to be 8 times 6. We'll do 8 times 6 to get 48 feet squared. To find the area of the shaded region, again, we need to subtract those. 224 minus 48 is going to get us 176 feet squared for the area of the shaded region. Now again, this is just a prerequisite skill. We are going to build on this with some linear expressions next week, but I wanted to make sure we saw some simple area of the shaded region questions like 1 and 2, area of the big rectangle minus area of the little rectangle. And then problems like 3 and 4 where we aren't given those outer dimensions and have to find them. It's going to be set up very similarly in our notes that we'll have next week, but we will build on this. Thanks for listening.